All right, on to primes and factorization. You've just watched the sieve of, I always get his name wrong, but that guy. And you did the assignment that you had to hand in. So we are now going to talk about prime and composite numbers and factorization. All right, so if we're looking at prime and composite numbers, again, the prime numbers are going to be numbers that don't have any factors other than 1 in itself. So if you think back to our factor lists that we made in the last video, this is going to be, numbers where the only ones we can get out of that list are like 1 times the number. And composite's going to be any time we can make our factor list and have anything other than 1 in that number. So anytime we can have 2 or more pairs. So if we look here, 3 is going to, 3 is going to be prime. Because again, if I take 3, I can only get 1 and 3. 57 is going to actually be composite. And again, if you are thinking like, how am I going to know this, or what, we can use our multiplication chart. So let me grab it for a second. I can grab 19 times 3. That's a factor pair other than 1 times itself, other than 1 times 57. So that's why it's composite. All right, 29, the only pair that I can have is 1 times itself, or 1 times 29. So that is going to be prime. 34 is an even number. Any even number other than 2 is going to be composite. And 17 is going to be prime. All right, circle all the primes. So realistically, I'm going to look for any numbers that are composite, and I'm going to actually cross them out. That's going to be the way I would do it. So the first thing I would look for is any even numbers. I'm going to get rid of any even numbers other than 2. So I'm going to cross out 28, 26, 38, 20. 2 I know is prime, so I am going to circle that one because that's just my kind of my oddball number. It's the only even number that is prime. So then I come back and I'm going to look for numbers that are divisible by 3. So 3, 6, 9, 12, 15. So I'm going to get rid of them. So again, I'm getting rid of the composites. That's how I'm looking for my primes. So 9, 15. Off the top of my head, those are the only ones that I know are divisible by 3. I'm going to get rid of anything that ends with a 5 because anything that ends with a 5 is divisible by 5. So I can get rid of 5. I can get rid of 35. I'm going to get rid of 49 because I know that's 7 times 7. I'm going to get rid of that's it. Now 1 is a special number. It's not prime. The reason is because it's 1 times 1. If you watch the sieve video, you'll see that. So that is not prime. 67, 71, and 23. I think those are all my primes, but I'm just going to kind of check back. And I know that 71, 67, 23, and 2 are my prime numbers. All right. So now drawing factor trees, it's exactly what it sounds like. Instead of listing my factors, I'm going to draw a tree for my factors. So here's where I want you to get used to the directions. If you want to list your factors, you don't want any repeats. So this was on the previous sheet. You want to list pairs of factors and you don't want any repeats. Okay, so list factors. You want the pairs and no repeats. Okay. Factor trees, you want to break them down into prime numbers. Okay. So that it looks like a tree. I mean, literally it looks like a tree. You can have repeats for this. So what we want to do, we want to start, there's multiple ways you can do this. So yours might not look like mine. You just want to pick a number that it's divisible by. So if what you want to do, what I like doing is if it's an even number, I use the number 2. And I use the number 2 until I can't use it anymore. So I'll show you what I mean. I'm going to go like this, and I'm going to create branches. This is why it's called a tree. Okay, and I'm going to write the 2 here. I always write my prime number to the left. That's just how I do it. And then you basically, again, so 2 and 18. Now 2 is a prime number, so I circle that. That's the end of my, like, just like a tree, your branches end. Your branches end when you have a prime number. 18 is not prime, so you have to keep going. So I break this down again into 2 branches. It's even, so I use 2 again. So 2, and 2 times what equals 18. So again, here, so I come back here, and it's 2 times 9. Again, these 2 numbers are always multiplied, equaling to that one, right? So 2 times 9 gives me 18. I'm circling the 2 again because that's prime. I'm breaking down 9 now. 9 isn't even, so I can't use 2 again. I have to use another number where it's divisible. So again, I say 3 and 3, and 3s are both prime. Okay, so this is my factor tree, and I'm done. 2, 2, 3, 3. You're done when all of your branches, basically when you have circles at the end of all your branches. You cannot end until you have a prime number at the end of all your branches. So you are done when you have a prime number at the end of all your branches. Sorry, my handwriting is tough to read there. All right, so let's look at 25. I'm going to branch it off. I can't do 2 because it's not a even number. I know that a factor of 5, something that divides 5, because it ends with 5, and this is where your divisibility rules kind of help you out, is 5. So 5 and 5, and those are actually both prime numbers. And again, that chart that you made with the sieve will help you out. So you're actually done because 5 is done. It's a prime number, and you have it for both of them. All right, 100. So it is even, so I'm going to do 2, and 2 times 50, and 2 is done. 50 is even, so I'm going to do 2, and I have 25. 2's done, and now I have 25. Well, I just did 25. I know it breaks down into 5 and 5, so I'm done. So my tree looks like this, 2, 2, 5, 5. All right, 48. So I have 2, and that gives me 24, because 2 times 24 gives me 48. 2's done. 24, still even, so I'm going to do 2 again. 2 times 12. Circle the 2 because it's prime. 12, I can do 2 and 6. Now, again, you might say like, okay, well, I wouldn't have done 2 and 6. I would have done 3 and 4. That's fine. I'll show you that in a minute because you'll see that you get the same thing. So I get 2 and 6, and then 6, you get 2 and 3. So those are both prime, so I'm done. 2, 2, 2, 2, 3. Now, you might say to yourself, like, okay, well, I would have done 6 and 8. That's fine, too. Neither of those are prime, and that's okay. Then 6 would have done 2 and 3, both prime. 8 would have been 2 and 4. 2 is done, and then 4 would have given you 2 and 2. So now I get 2, 3, 2, 2, 2. But notice I still have 1, 2, 3, 4 2s and 1 3. 2, 2, 2, 2, 3, 4 2s and 1 3. Either way, your factor trees are the same. All right, let's go on to the next page. So if I look, and I'm looking for 57, it's right, oops, I have to grab a pen. 57 is right here, so that is 19 times 3. So because multiplication chart, if I look for these numbers, I'm not going to see these. And the reason I'm not going to see these is because these do not have any factors. I definitely know 23 doesn't have any factors. 67 does not either, and 71 definitely doesn't either. So I come to multiplication chart. Really, you want to find anywhere you see the number 36 in here. So, you know, you can find, like right here, I found 36. I grabbed 36 on 4 and 9, okay? But you could grab 36 right here, okay, which is 12 and 3. You could grab 36 here, which is 18 and 2. The only part you really don't, or the only spot you really don't want to grab 36 is 1 and 36. The number 1 is not going to help you on this. So multiplication chart, and you do it that way. So 2 and 18, that's the one I used. So 2 and 18. Here, now I'm working with 18. Well, I'm still in the 2 column, and that's 9. Go over here and I say, okay, well, now I'm looking for 9. Well, I see 9 right here. So 9 is 3 and 3. 3 and 3. All right, so now write the prime factorization of the number. So third direction, and actually the first direction was back in the previous task. So the first direction, like we talked about, was just listing factors. So this was like, you know, you did this and you did 1 times 10, 2 times 5. Then it was factor tree. And that was 2 and 5, and you circled them like that. And now it's the prime factorization, and I'll show you that in a minute. Okay, you actually start it the same way. So you're going to first do your tree. So we're going to start by doing our tree. So we're going to start off the same way. So start with tree. Okay, so we get 2 and 32, circle your 2. 2 and 16, circle your 2. 2 and 8, circle your 2. 2 and 4, circle, whoop, not your 4, 2. 2 and 2, circle both 2s. With a factor tree, you would have stopped here. 2, 2, 2, 2, 2, 2. When they say prime factorization, you want to take it one step further. Your prime factorization is 2 times 2 times 2 times 2 times 2 times 2. And how many did we have? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We had 6 there, right? Or 2 to the 6th power. Now, we haven't quite talked about exponents, but we're going to kind of push through that to write it correctly. So what you want is the number that you have. So how many 2's you have here. Okay, the base number, and how many you have as your exponent. So what you have, how many you have. Okay, this is called your base. This is called your exponent. All right, this is called your exponent. This is called your base. This is how many you have. This is what you have. Okay, so let's try it with the 72. 2 and 36, circle your 2. 2 and 18, circle your 2. 2 and 9, circle your 2. 3 and 3, circle your 3s. So now this one's a little bit different because we have two numbers. So we're going to write it 1, 2, 3, and then 1, 2. So we have 2 times 2 times 2 times 3 times 3, which is really 2 to the third times 3 to the second, because I have 2 3 times and I have 3 2 times. Okay. Let's try another one. All right, 80. I have a lot of 2's to pull out because they're evens. 2 times 40, I circle my 2. 2 times 20, I circle my 2. 2 times 10, I circle my 2. 2 times 5, I circle my 2 and my 5. I have 1, 2, 3, 4 2's. 2 times 2 times 2 times 2. And I have a 5. So that means I have 2 to the fourth times 5. I have 4 2's and I have 1 5. If you wanted, you could put a 1 as an exponent on the 5 because you have one of them. Really, the exponent is telling you how many of the number you have. What you have, how many you have. Okay? All right, let's do the 120. I have 2 times 60, circle the 2. 2 times 30, circle the 2. 2 times 15, circle the 2. 3 times 5, circle the 3 and the 5. Remember, you're circling the number if it's prime. Prime numbers, 2, 3, 5, 7, 11. Again, the common ones are really going to be 2, 3, 5. Those are the ones that you're going to see a lot. So I have 1, 2, 3 2's. I have 1 3. I have 1 5. So I have 2 times 2 times 2. I have times 3 times 5. 2 to the third times 3 to the first times 5. All done. All right, if you have any questions, let me know. If not, keep going.